Alright, so now what I want to do in this next video is I want to review what we've done on the first few videos. So if you still have questions, hopefully this will answer them and give you a few extra information. And we're also going to do a little quick Algebra 2 review with this first one. So first, my parallel lines and proportional parts. So when I look at this one, I can see I have 3 parallel lines and 2 transversals. So I know that these 4 little pieces here are proportional, and I can either go 5x over x plus 12 equals 3x over 12 and go in between my parallels, or I can stay on a transversal and go 5x to 3x and then x plus 12 to 12. I'm just going to go the way that they're written and make it 2 fractions this way. So I'm going to do 5x over x plus 12 is equal to 3x over 12. Okay, and then this is going to need to be cross multiplied. So here I'm going to multiply, let's start with the easy side first, 5x times 12, which is going to be 60x, and that's going to be equal to, then I'm going to do the other side, and this one's a little bit harder because sometimes we go 3x times x and then we forget we have to multiply it to the 12 also. So this is really 3x times, in parentheses, x plus 12. So we don't forget to multiply it to both of those. Okay? Now, it has been a while since we had to multiply an x to an x, right? So we need to remember that. It's going to be 60x equals 3x times x is 3x squared. And then 3x times 12 is going to be, 3 times 12 is going to be 36x, because it's 3x times 12, so 36x. So here we have a quadratic. Okay, so we need to think back to algebraic reasoning in Algebra 2, and even we did it a little bit in Algebra 1. We need to think back to quadratic equations and how to solve those. In order to solve a quadratic equation, one that has a square in it, we have to set it equal to 0. It's close to 0, except on one side I don't have 0, I have 60x. I have one term on the left side. So what I'm going to do is I'm going to move it to the other side by subtracting 60x on both sides. And since I need to subtract it from a like term, I'm going to subtract it from the 36x. Okay, so then I end up with 60x minus 60x is just 0 equals 3x squared. And then I have a positive 36 and a negative 60. So when I subtract there, when I grab my calculator and I subtract, oops, that's not my calculator, 36 minus 60, I end up with negative 24, so minus 24x. Then what we have to do is we factor binomials if we need to, or we can see if there's a greatest common factor. Now both of these have an x, so I know I can take an x out of both terms, and then also the 3 and the 24 are both divisible by 3, so I can take a 3 out and I can take an x out of each term. So what I end up with is 0 equals, I'm going to take out a 3x from each term. When I take a 3x, when I divide the 3x squared by 3x, when I take it out, all I'm left with is just x. So that way 3x times x gives me my 3x squared. Then when I divide this one, my negative 24x by 3x, 24 divided by 3 is 8. And it's going to be a negative 8, so that way I get a negative 24 when I multiply back in. And then there's not going to be an x or anything there because 3x times negative 8 gives me my negative 24x because the x is already there. Okay? So now I have these two factors that multiplied together makes 0. The only way you get a 0 when you multiply two things together is if one of them is 0. So either the 3x equals 0 and or the x minus 8 equals 0. Okay? The 0 product rule. To solve the first one, we just divide by 3, and we end up with 1x equals 0. So x equals 0 is my first solution. If I were to graph it, that's where my parabola would hit the x-axis, right? And then my other one, I need to add 8 on both sides. And I'm going to get x equals a positive 8. Okay? Now, in Algebra 2, we gave both of those answers. We said those are both good answers. In geometry, you have to make sure that both of them work. So if I come over with x equals 0 and I were to plug it in, 5 times 0 is 0. 3 times 0 is 0. 0 plus 12 is 12. And then this one is still just 12. Now think about this. Can a segment that has length equal 0? No, it cannot. So what that means is my answer cannot be 0. If I end up with a segment that equals 0 or a segment that's a negative number, then that answer will not work. Okay? But my other one, when I plug the 8 in, 5 times 8, that I can do. 5 times 8 is 40. 3 times 8 is 24. Then when I come down here, 8 plus 12 is 20. So look, 40, 20, 24, 12. Notice my bottom two numbers are exactly half of my top two numbers. So they are proportional. My correct answer for this problem is x equals 8. Okay? All right, let's look at the next one, my midsegment. Okay? For midsegment, in the diagram below, TO equals 10. I'm going to go ahead and label that. TO equals 10. GO equals 6. GO equals 6. CT equals 24. So this whole bottom is 24. DO and G are midpoints. So D is a midpoint, meaning this piece matches with this piece. O is a midpoint, so this matches with this, which is 10. So both sides are 10, which means this whole piece here is 20. And G is a midpoint. If the whole side is 24, then that means this is 12 and this is 12, so that G is a midpoint. Okay? What is the perimeter of triangle CAT? So CAT is my whole big giant triangle. So if I want to know the perimeter of the whole big giant triangle, I need to add the three sides together. I already know that this one is 20. I already know that this one is 24. I need to know how long this side is. Well, remember, this side is going to be twice as long as the parallel midsegment, which is 6. So that means each of these little pieces are 6, and this piece here is 12. So my perimeter of triangle CAT equals 12 plus 20 plus 24, which is 6, 2, 4, 5, 56. My perimeter of triangle CAT equals 56 units. Okay, it didn't ask me for DOG, but let's look at that one real quick. If I wanted the perimeter of DOG, if this piece is 6, this is going to be half of the side that it's parallel to, which is 24, so 12. And then this one here would be half of the side it's parallel to, so it would be 10. So my perimeter for triangle DOG is going to be 12 plus 6 plus 10, which is 28. Now notice triangle DOG is half of triangle CAT because these lengths are all half of the side lengths of the triangle. Okay? All right, and then one more little review for this lesson, my triangle proportionality, the last one. We want to determine the length of each segment. Remember, if we're trying to find one of these, if we're working with one of the parallel sides, we have to redraw our triangles. Okay? If we're working with all just the left side and the right sides together, then they're proportional and we don't have to worry about redrawing the triangles. So let's see what we're looking at. Okay? The first one, I'm trying to find BC. Okay, so since it's not one of the parallel sides, I can set up a proportion. I can ignore this little bottom section here, and I can see that I'm going to have 5 to 5 is going to equal 6 to whatever this is. We could call it x. So 5 to 5 will equal 6 to x will give me BC, which you can probably tell what it is, right? If these two are the same, they're going to reduce to 1. So for this side to reduce to 1, it's going to have to also be 6. But we can cross multiply and check. 5 times x will equal 5 times 6. So 5x will equal 30. Divide both sides by 5. And x equals 6. So BC equals 6. Okay? The next one it's asking me for is CD. So this time I want this piece. Now, I know this first one was really simple, and so we could cover this part, and we could do 5 to 7 equals 6 to whatever this is. I've already used an x, so I'm going to call it y. But I like to try to stay away from using anything that I mathematically figured out just in case I made a mistake. This one was pretty simple, so I'm pretty confident I didn't. And either way, I'm still going to get the same fractions. Because look, here I'm going to have the left side to the left side equals the right side to the right side to be able to find CD. So 5 to 7 is going to equal 6 to y. This one we are going to have to cross multiply because it's not 5 to 5, which is 1, right? It's 5 to 7. So I am going to cross multiply this one and get 5 times y is going to equal 7 times 6. Okay? Divide both sides by 5. And y, when I do 42 divided by 5, I think that's 8.1, but let me make sure. 42 divided by 5 is, 8.4. 42 divided by 5, 8.4. Y equals 8.4. Okay? And then the last one it asks me for is FC. FC is one of the parallel sides. So in order to do that one, I'm going to have to redraw the triangles. I'm going to have to redraw this one that has the FC on it, the whole triangle, where I'm trying to find FC. I know this left side is 5 and 5, so that's 10. This side is 6 and 6, so my right-hand side is 12, but just in case I made an error there, I'm going to try to avoid using that. Okay? Then when I look at my other triangle, the only other parallel number I have information about is this bottom side, so that means I need to use the big triangle. So my big triangle, EAD, is 5, 5, and 7 for this side, so that's 17, and 15 for this side. And even though we found this is 6, this is 6, and this is 8.4, but I'm not going to write that in case I made errors on these two. Okay? So now, when I look, I can set up a proportion using those two triangles. And anytime you have a parallel side, you want to redraw your triangles. You have to decide which one you want to be the numerator and which one you want to be the denominator. And it doesn't matter which. I usually just whichever is further left, I say is up, and further right, I say is down. So I'm going to compare my left side of the triangle in the numerator to my left side of the triangle in the denominator, equal to the bottom of the triangle, numerator, and bottom of the triangle, denominator. So now this, I'm ready to cross multiply. 17 times x and 15 times 10. I'm going to divide both sides by 17. And so x is going to equal, I probably shouldn't have called it x because I already had an x in there, but it happened. So x is going to equal 150 divided by 17. I get this decimal. And remember I said I want to round decimals to 3 places. So it's, excuse my app, 8.8, let's see, 1, 2, 3. 8.83 is my third number, right? But to see if I need to round that up, I'm going to look at the one after it. It's a 5, so I do want to round it up. I'm going to round that 3 to a 4. So I'm going to say 8.824 for the distance from F to C. Okay? So there is a review, a little mini review of the 3 topics that we discussed today: parallel lines and transversals, mid-segments, and triangle proportionality. Okay? If you have any questions, please make sure that you're asking after sync time during each daily tutoring session of your teacher, or sending an email or something. If you need any extra additional help with these, please make sure you're asking. Thank you so much for watching. Bye!